So if I asked you to picture a fundamental building block of the universe, you'd probably picture a tiny dot, right? Like a solid microscopic billiard ball.
Right, yeah.
Like you take a sharply pointed pencil, you tap it on a piece of paper, and your brain just tells you, there it is. Physical matter, a point.
Yeah. It's the most instinctive assumption we make as humans, really. We categorize reality by what is tangible, visible, solid.
Right.
We want the universe to be built out of tiny bricks.
Exactly, tiny bricks. But what if I told you that tiny brick doesn't actually exist? What if physical matter at its absolute core is an illusion, and the universe is closer to a two-dimensional hard drive projecting a three-dimensional hologram?
Which is a wild thought.
It is wild, and today's deep dive is going to completely dismantle how you perceive reality, dimensions, and the physical space around you. We're using a really fascinating stack of theoretical physics, cosmology, and even biology sources to systematically deconstruct how the universe is actually built. And our mission today is to take you on a step-by-step journey from that microscopic pencil dot all the way up to the edge of a black hole. So, okay, let's unpack this. We have to start by just throwing out that pencil dot, because everything our intuition tells us about a quote-unquote point is wrong.
It is entirely upside down.
Yeah.
To truly understand the architecture of reality, we're looking at what's called rule ontology frameworks today.
Okay.
Specifically, we're drawing from Deng Zhenghong's philosophical framework and something called the 0 to the power of 0 equals 1 creation axiom.
0 to the 0 equals 1. Okay.
Right. And according to these frameworks, a fundamental microscopic particle is not a solid entity at all. It is what they call a topological condensation of a rule field.
Okay, hold on. Topological condensation of a rule field. That is a massive wall of jargon.
Making videos is difficult, and independent thinking is even more difficult. If you have the ability or need it, please consider supporting me by clicking on the zero-dimension shop products in the bottom left corner of the video.
One concept.
Yeah, please do.
In traditional math, 0 to the power of 0 is often treated as an undefined singularity.
Right, it breaks the calculator.
Exactly, it breaks it. But in this specific philosophical framework, it represents an absolute balance of nothingness.
Nothingness.
Yeah, it's a double zero steady state where both the carrier and the dimension hit absolute zero simultaneously.
Oh, okay, so it's like the ultimate state of nothing.
Yeah, but it's a perfectly balanced nothing. And from that absolute perfect balance, it spontaneously generates a constant unit element, which is 1.
Okay.
That one is the origin point. It's not a grain of sand. It is pure, concentrated mathematical order.
I think I'm following. So it's less like a physical brick and more like a single line of code initiating a program.
Yes.
Like if you zoom into a highly detailed digital photograph, you don't find smaller pictures of a tree or a cloud.
Right. You just find pixels.
You just find individual pixels, which aren't stuff. They are just numerical values of light and color.
Mm-hmm.
But here is my pushback, though. If a fundamental point isn't physical matter, but just a condensation of rules and mathematical information, how does that actually build the physical world I'm currently knocking my knuckles against?
Well, that brings us to step 2 of this architecture. Because a point is just an informational node, right? We have to look at how the universe essentially stacks its dimensions to form the physical reality we bump into.
Okay.
Our sources synthesize this into a very clear 4-layer dimensional hierarchy.
Walk me through that. How do we get from a line of code to a physical table?
Okay, we start at layer 1, which is 1D, the source point.
This is 0 to the 0 thing.
Exactly. This is that mathematical origin we just discussed, the absolute balance. It's this foundational seed where the rules of reality originate.
Okay.
But a seed needs an environment to grow in, which leads to layer 2, 2D, information.
So a two-dimensional plane.
Yes. This is the layer where all the data, all the rules, and the blueprints generated by that 1D source are actually stored and distributed. You can think of it as an informational surface or like a cosmic blueprint. And then once that blueprint is established, we get to layer 3, which is 3D matter.
Our world.
Right. This is the physical projection of that 2D information. It is the manifested reality. Particles, planets, your microphone, they're all 3D projections of 2D data.
Wow.
And finally, we add layer 4, 4D spacetime. This adds the arrow of time to our 3D volume, creating a dynamic arena where that manifested matter can evolve, move, and, experience relativity.
Okay, it's a struggle to wrap my head around this because my eyes are literally looking at a solid 3D microphone right now.
Sure.
But you're telling me it's essentially rendered code. So what does this all mean? The tangible world is a byproduct of a 2D informational blueprint.
Yeah. Researcher Brian Whitworth, who's heavily featured in our stack today, he argues that the physical world operates remarkably like a virtual reality.
Oh, I love that analogy.
Right. In a VR simulation, the 3D world you experience inside the headset doesn't exist in and of itself. Mm-hmm. Every mountain, every lighting effect, it depends entirely on the 2D information processing happening on a silicon computer chip outside of that virtual space.
Right. It's just code on a hard drive somewhere. It's a great analogy. But VR is man-made. So if 2D is the true information layer of the actual physical universe, where is the cosmic computer chip? Where do we see this proven in mainstream physics?
Well, we see it in one of the most robust concepts in modern theoretical physics, actually, the holographic principle.
Okay.
This was championed by legendary physicists like Leonard Susskind and Gerard de Hooft. And they were wrestling with a massive problem involving black holes.
As you do in physics.
As you do. And they discovered something mind-blowing about entropy, which in this context, we can just call information capacity.
Okay, information capacity, like how much data you can fit in a space.
Right. So normally, if you want to pack a room full of moving boxes, the number of boxes you can fit depends on the 3D volume of the room. Length times width times height.
Makes sense.
But Susskind and Hooft realized that for the universe at a fundamental level, the maximum amount of information you can pack into a region of space is not proportional to its 3D volume. It is proportional only to its 2D surface area.
Wait. Let me make sure I'm hearing this.
Yeah.
The amount of information you can pack into a room doesn't depend on how big the room is in 3D. It only depends on the square footage of the walls.
That is the exact mathematical reality.
That is insane.
It is. Suskind's work shows that our entire 3D world can be perfectly projected onto a distant 2D viewing screen without losing a single piece of information.
Oh, wow.
And on this 2D surface, one bit of fundamental information occupies exactly one Planck area.
Remind me, what is a Planck area?
A Planck area is the absolute smallest measurable unit of area in physics. Imagine a cosmic lattice, like a microscopic grid, where each tiny square is one Planck area, and it's either holding data or it isn't.
Like a pixel.
Exactly like a pixel.
Yeah.
That flat 2D screen codes the complete description of our 3D reality.
Are you saying the universe is quite literally a 3D hologram projected from a 2D cosmic hard drive?
Conceptually, yes.
Yeah.
And this 2D layer doesn't just act as a storage drive. It is a vital protective shield.
Protective shield? What is it protecting?
Well, we see this most clearly when we look at the most extreme, terrifying objects in the cosmos.
Black holes. The places where physics supposedly goes to die.
Exactly where physics was thought to break down. When matter falls into a black hole, it gets dragged toward a singularity, a 3D point of infinite density,
right,
where all of our classical laws of physics just shatter.
Right.
Now, there was a massive debate about this called the black hole information paradox.
Okay.
If the physical matter falling into the black hole and all the quantum information that made up that matter hit the singularity and was permanently destroyed, it would violate the fundamental laws of quantum mechanics.
Yeah.
Because information cannot be deleted from the universe.
Wait, so if the 3D matter gets crushed into nothingness at the center, how does the universe protect the data?
It projects it onto the 2D surface of the black hole, the event horizon. The boundary where light can no longer escape.
The black sphere we see in all those space telescope images.
Yeah, that boundary is a 2D surface. The information of every star, planet, or dust cloud ingested by the black hole is intercepted and preserved on that 2D event horizon.
That is wild.
And there is a concept called the firewall hypothesis, which suggests there is an intense layer of high-energy particles right at the horizon. This firewall incinerates the infalling 3D matter, essentially translating its physical structure back into pure 2D information.
So it burns up the physical thing and just saves the code.
Yes. The universe saves the data on the 2D screen to protect it from being permanently lost in the 3D singularity.
Wow. The 2D layer intercepts the file and backs it up before the 3D hardware crashes. That is incredible.
It really is.
And since black holes are where these 2D information screens are ostensibly visibly doing this heavy lifting, we have to look at how they connect to the rest of the universe. They can't just be isolated glitches, right?
No, they aren't isolated at all. And this brings us to brain cosmology, which is a major structural concept arising from string theory and M theory.
brain with a B-R-A-N.
Yes, B-R-A-N-E.
Right.
In this model, our entire 4D universe, the 3D space plus time that we live in, is a membrane.
Okay.
Physicists call it a brain for short. And this brain is floating in a vastly larger, higher dimensional space called the bulk.
Okay, a membrane floating in a bulk. Help me visualize that.
Sure. Imagine our 3D universe is the surface tension of a pond.
Yeah.
And we are water bugs skating along the top.
Okay, water bugs on a pond.
Right. We can only move left, right, forward, or backward across the surface. We have absolutely no sensory concept of the deep water miles below us or the sky high above us.
We just know the flat surface.
Exactly. That extra unseen dimensional space is the bulk.
Yeah.
And in brain cosmology, a black hole's event horizon acts as a foundational structural opening. It's a localized interface in our 3D world that punctures through and points directly toward those higher dimensions.
I love this visual. So the black hole horizon is like a drain in a 3D sink. Like the matter swirls around the basin of our universe, but when it goes down that drain, it connects directly to the unseen plumbing of the higher dimensional bulk.
And that unseen plumbing actually solves one of the greatest, most frustrating mysteries in modern physics.
Which is?
Why gravity is so incredibly weak.
Is gravity really considered weak? I mean, it feels pretty strong when I drop my phone and it holds the Earth around the sun.
It seems strong to us because massive objects like planets compound it. But on a fundamental level, it is pitifully weak.
Yeah.
Think about a simple paperclip.
Okay.
You can pick up that paperclip with a tiny, cheap refrigerator magnet.
Yeah.
That tiny magnet is effortlessly overpowering the gravitational pull of the entire planet Earth.
Oh, wow. I never thought about it like that. Earth is pulling it down, but a little magnet just picks it right up.
Right. Electromagnetism, the strong nuclear force, the weak nuclear force, they are exponentially, vastly stronger than gravity.
So why is gravity the odd one out?
Well, brain cosmology suggests that those three stronger forces, electromagnetism and the nuclear forces, are made of open strings that are permanently glued to our 3D brain. They can't leave the surface of the pond.
Okay.
Making videos is difficult,
Exactly.
and independent
But
thinking
gravity
is
is no
even more
different.
difficult.
Gravity's
If you
transmitted
have
by
the ability or
hypothetical
need
particles
it,
called
please
gravitons,
consider supporting
which
me
take
by
the
clicking
form
on
of
the
closed
zero
strings.
dimension shot products
Because
in the
they're
bottom
closed
left
loops
corner of the
aren't
video.
tethered to our 3D brain.
Oh, so they can leave.
They are free to leak out and bleed into the higher dimensional bulk. We only experience a tiny diluted fraction of gravity's true strength in our universe because the vast majority of it is flowing down that drain into the bulk.
Okay, that completely changes how I view gravity. But let's follow this logic. If gravity and space-time are actively built by the entanglement of this information, which clusters heavily around these black hole drains, what happens when that information is removed? What happens to physical space when there is no data on the 2D screen?
It's a great question. To see what happens when information is removed, we have to point our telescopes in a region of space called the Booth's Void.
The Great Nothing.
The Great Nothing.
This is a massive, roughly spherical region of space in the constellation Booths, and it is nearly 200 million light years across.
It's unfathomably huge.
Just to put that staggering scale into perspective for people, a region of space that size should naturally contain about 2,000 galaxies, but the Booth's Void, it only has about 60.
Yeah.
It is a terrifying expanse of emptiness.
And the standard model of cosmology that most scientists use today, known as lambda cold dark matter, suggests voids like this form over billions of years, simply by smaller voids merging together as gravity pulls galaxies toward denser filaments.
Just kind of slowly drifting apart.
Right. But if we view it through the lens of information and rule ontology, something much more active and profound is happening. We look to an award-winning essay by physicist Mark van Ramsdonk. He mathematically argues that classically connected space-time is actively built and sewn together by quantum entanglement.
Let's define our terms here for anyone not carrying a physics degree. When we say space-time is built by quantum entanglement, what exactly is tangling together? Because the sources mention something called degrees of freedom.
Yeah, a degree of freedom in quantum mechanics is simply an independent way a system can change or hold information, like a particle's position, its momentum, or its spin.
Just variables.
Basically. And Van Ramsdonk demonstrates that space isn't just an empty container that objects sit inside. Space itself is generated by the entanglement, the linking of these quantum degrees of freedom.
So they link up.
They share information, and that sharing weaves the fabric of space.
So if sharing information sews space together, breaking those links must do the opposite.
He proved that mathematically as well. If you take two regions of a quantum system and you artificially decrease the entanglement between them, if you unlink their degrees of freedom, the physical distance between those space-time regions literally goes to infinity.
What do you mean goes to infinity?
The area separating them shrinks to zero, and they pinch off from each other. Disentangling information literally stretches and tears regions of space apart.
Wow. And here's where it gets really interesting, because this changes everything about how we view the Boots void. If space is created by information linking together, then a 200 million light-year void isn't just empty space where stuff coincidentally happens to be missing.
No, it is what we call a cleared information area. It is the macroscopic physical manifestation of disentanglement.
Like the universe deleted the files.
The universe essentially transferred the foundational information out of that region. The quantum degrees of freedom unlinked, and that lack of entanglement actively pushed the surrounding space apart, leaving a massive, desolate void in its wake.
That is wild.
It reframes nothingness not as a passive lack of matter, but as an active physical process. The universe systematically deleted the 2D information, and the 3D space hollowed out.
So, if vast areas of space like the Boots void can be actively cleared of manifested matter, how does the universe decide what information actually gets manifested into 3D reality in the first place?
Yeah.
Like, if the universe is a 2D hard drive, what exactly presses print to make an object 3D?
This is a crucial piece of the puzzle, defined in our sources as Deng Zheng-Honghui's concept of selective manifestation.
Selective manifestation.
This is the philosophical underpinning of what quantum physicists call wave function collapse. In quantum mechanics, a particle exists in a superposition, a blurry cloud of all possible states and locations, until it is forced to collapse into a single, definite 3D reality.
This is the famous Schrödinger as cat thought experiment, right?
Exactly.
The cat is both alive and dead until you open the box.
Mm-hmm.
But pop culture always says this collapse requires a conscious observer to look at it, which has always felt wildly mystical to me. Like, why would the universe care if a human is looking at it?
The rule ontology framework completely agrees with you.
Yeah.
It's not mystical, and it absolutely does not require human consciousness. Selective manifestation is a strict truncation rule driven by the rule field itself.
Okay.
The universe forces a collapse when a quantum system interacts with a macroscopic system. Specifically, when it crosses a critical threshold of complexity, which physicists estimate is roughly 10 to the power of 23 atoms.
Okay, why that specific number? Why does 10 to the 23rd power suddenly trigger reality to manifest?
Because of something called symmetry breaking and phase differences.
Mm-hmm.
Imagine you are standing in an empty stadium with just two other people.
Okay.
If they both whisper a different song, you can hear both songs simultaneously. That's a superposition. Your brain can hold both pieces of conflicting information.
Sure.
But if you fill that stadium with 1 trillion people and they all whisper different songs, it instantly becomes a single chaotic wall of white noise. The individual data is lost.
It overloads the system.
Exactly. When a system reaches that threshold of 10 to the 23rd atoms, the sheer number of degrees of freedom causes the underlying rule field to undergo symmetry breaking.
Okay.
The overlapping possibilities are forcefully screened out, the phase differences are smoothed over, and the universe mandates that only one logically self-consistent reality is allowed to manifest in 3D space.
So it simplifies it.
The 3D manifestation is essentially a cosmic filtering system to prevent the universe from crashing under the weight of overlapping data.
That brings incredible clarity to a very dense topic. The universe hits a critical mass of complexity, and the 2D code runs a truncation rule to render a solid 3D object so it doesn't break itself.
And if we connect this to the bigger picture, it solves the most embarrassing problem in modern astronomy: dark matter and dark energy.
Oh.
Which together make up about 95% of our entire universe. Right. We can't see them, we can't emit light from them or touch them, but we know they exist because we can measure their gravitational pull bending light around galaxies, and we watch dark energy accelerate the expansion of the universe.
So how does selective manifestation, this 3D rendering rule, explain something completely invisible?
Because the vast majority of the universe's foundational rules and topological structures remain unmanifested.
Oh.
They simply never cross that complexity threshold to be rendered as 3D matter.
Oh.
The rule field ontology suggests that dark matter and dark energy are exactly that. They are the underlying, unmanifested rule field.
That is fascinating.
They are the background operating system. They exert gradient forces across the cosmos, which we perceive as massive gravitational pulls and cosmic expansion, but they remain hidden in the informational dimensions because the truncation rule hasn't selected them for 3D printing.
So the 95% of the universe that scientists call missing isn't actually missing. It's just the unrendered code running behind the scenes. We are sailing through an ocean of invisible data.
We are a 3D projection navigating through a sea of unmanifested rules.
Man, we have spent this entire deep dive exploring how unseen rules project into lower dimensions, and how the true nature of reality is hidden from us simply because we are trapped in our specific dimensional hardware, which actually perfectly mirrors a biological limitation right here on Earth.
Yes.
And I want to bring this up because it's a very common internet myth that needs to be explicitly busted today.
The misconception about ants.
Yes, you see it on forums and science pages all the time. People state as a fact that ants are 2D creatures. The logic they use is that because an ant walks on a flat surface and follows pheromone trails on the ground, it fundamentally exists in 2 dimensions.
Yeah, and this myth perfectly illustrates the danger of confusing physical reality with sensory processing.
Right.
From a physical and biological standpoint, an ant is absolutely, without question, a complete 3D creature.
It's not a flat drawing.
No, it has length, width, and height. It possesses a complex digestive tract, an exoskeleton, and physical volume. It occupies 3D space identically to how a human does.
Right, but the myth persists because of how their brains process their environment.
The confusion arises because an ant's visual perception, its chemical tracking, and biological activity heavily depend on flat planes. Their sensory apparatus is highly optimized for evaluating the world on an X and Y axis.
Just left, right, forward, back.
Consequently, they often cannot effectively process the Z-axis height. If you hold a piece of food directly above a foraging ant, just at a physical reach of its antenna, it will often act as if the food doesn't exist. Its sensory processing doesn't naturally render vertical information.
I always think the best way to visualize this is to think of playing a classic top-down 2D video game like Pac-Man on a fully 3D computer monitor.
That's a great way to put it.
Right. The computer hardware processing the game is 3D. The monitor sitting on your desk is a 3D object. But the character inside the game is completely restricted by 2D sensory processing.
Making videos is difficult, and independent thinking is even more difficult. If you have the ability or need it, please consider supporting me by clicking on the zero-dimension shop products in the bottom left corner of the video.
Because just as the ant fails to perceive the 3D reality towering directly above its head, we as human beings struggle to perceive the 2D informational rules and the higher dimensional bulks that govern our universe. We can only see the 3D rendered matter our brains are biologically equipped to process.
That is a staggering paradigm shift. Let's try to pull all 7 of these steps together. What we've learned today is that our intuitive assumption about physical reality is just wrong. The universe isn't a collection of solid billiard balls. It is an informational projection. It originates from 1D mathematical sources. It is stored and fiercely protected on 2D screens like black hole event horizons. It is selectively manifested into the 3D physical world we bump into, and it dynamically evolves in 4D space-time. And when that information disentangles, it literally tears space apart, leaving voids like boots. And the vast majority of the universe remains unrendered, hidden from our limited biology.
It forces us to accept that the physical world is not the ultimate baseline of existence.
Right.
Information is the baseline. Space and matter are just the symptoms.
And that leaves me with a thought I just can't shake. If our 3D physical world is truly just the manifested projection of a 2D informational layer, what happens if humanity eventually learns how to access and rewrite the code on that 2D surface?
Oh, wow.
I mean, if reality is just rendered data, rewriting the source code wouldn't just be an abstract math trick. Could we locally delete the code for gravity to achieve interstellar travel? Could we teleport physical objects by simply copy and pasting their 2D information from one coordinate to another? Could we literally reprogram the physical universe around us?
The moment we stop treating the universe like a collection of physical rocks and start treating it like a programmable operating system, the limitations of physics become engineering problems. It is the ultimate frontier.
Definitely something to keep you up at night. Thank you for taking the deep dive with us today. Keep questioning the reality around you, and we'll see you next time.